Hello sir, my name is K.R. Shavarthan. I am from CSMA section and my topic is zinc air battery. In this we can see that contents of the topic: introduction to zinc air battery, basics of zinc air battery, construction of zinc air battery, working principle, electrode chemical reactions, applications and advantages, challenge and future prospects, and conclusion. Now we are discussing about introduction to zinc air battery. Zinc air battery is a type of primary battery. Primary battery means non-rechargeable battery which doesn't reuse after the chemical in that battery is finished. It has low shelf life, means if the chemical is finished in that battery, then the lifespan will be small now. Zinc air batteries have some properties like fuel cells as well. They have high energy density, lightweight design and environmental friendliness. Zinc, air, KOH solution means potassium oxide are the main components in this battery. Before the introduction, a brief backstory of zinc air battery. We know every experiment has its own backstory. Who was discovered it, who had discovered it, how was it discovered. So we can see now historical evolution. Emergence of zinc air battery in 19th century. The concept of zinc air batteries originated in the 19th century with initial experiments and developments by scientists exploring the electrochemical properties of zinc and air. Foundational researching. Notable contributions by researchers such as Charles Renard and George Leclanche laid the groundwork for early zinc air battery designs, with Leclanche cell being a peculiar modern zinc air technology. Here we can see zinc air battery is discovered in 19th century. Who were discovered was Charles Renard, George Leclanche. Now we are discussing about basics of zinc air battery. In this basic components are anode. Zinc metal electrode is taken as a anode. Cathode air through porous carbon plate means O2. Electrolyte KOH solution, potassium oxide solution. Separator to maintain integrity. Voltage produced 1.35 to 1.4 volts. Here separator is used for the division between the anode and cathode. It acts like wall of the anode and cathode. Here we can see the diagram of the zinc air battery, means construction of zinc air battery. Zinc metal is taken as anode and O2 is taken as cathode. In that KOH solution is produced and we can see the bulb and electrolytes means KOH solution, and here those are connected to the volts means 1.35 to 1.4 electrode volts. Now we can see how the process will be going on through the zinc air battery. Here we see the working principle of the zinc air battery. In zinc air battery, the oxygen formed from the air reacts at the cathode and forms hydroxyl ions, which migrate into the zinc paste and form zincate, releasing electrons to travel to the cathode. Here they are saying that oxygen from the air reacts at the cathode and forms hydroxyl ions. Hydroxyl ions means OH minus, which migrate into the zinc paste. Those OH minus are migrated to the zinc paste means zinc metal and form zincate ZnOH2S4, releasing electrons to travel to the cathode. Zinc metal is releasing electrons to travel to the cathode. The zincate decays into zinc oxide and water returns to the electrolyte. The water and hydroxyl from the anode are recycled at the cathode, so the water is not consumed. The reactions produce a theoretical 1.65 volts, but this is reduced to 1.35 to 1.4 volts in available cells. Here we can see the reactions will produce 1.65 volts, but this is reduced to 1.35 to 1.4 volts in available cells. Overall, we can see the chemical reactions. 2Zn plus O2, 2ZnO. Here zinc metal is reacted with the oxygen and forms complex molecule 2ZnO. Here we see anode reaction Zn plus 4OH minus ZnOH4 2 minus plus 2 electrons, and also fluid reaction ZnOH4 2 minus ZnO plus H2O plus 2OH minus. Though that H2O will react with the cathode reaction in the with O2. O2 plus H2O plus 2 electrons gives rise to 2OH minus hydroxyl ions. Overall, 2Zn plus O2 gives rise to 2ZnO. Here we see applications and advantages. Applications: hearing aids, electric vehicles, portable electronics, medical devices, grid energy storages, remote sensing monitoring, emergency backup power, military applications, consumer electronics, remote communication stations. And we also see the advantages: high energy density, lightweight design, environmental friendly, abundant raw materials, safe and non-toxic, cost effective, versatile applications, simple and scalable design, potential for grid level. Now we are going through the conclusion. Summary of key points covered in the presentation: evolution and importance of zinc-air battery technology, construction and working principles, applications, advantages and challenges, ongoing research and future prospects. Thank you, sir, for listening my presentation. I hope you like my presentation.